Hello, today we're going to do two examples of the Pythagoras Theorem. Here's our first example. We need to find B, which is this side of the right triangle, and here we have the Pythagoras Theorem. Okay, so what are these A, B, and C in this formula? A and B are the sides of the right triangle, the sides. They're also called legs. So the legs of the right triangle. And C will always be the hypotenuse. So what's my hypotenuse in this right triangle? This one here. It's always the longest side, but how do I know that if not all of my values here are numbers? Well, the hypotenuse is always the side that is right in front of the right angle. Here I have the right angle. So this one is my hypotenuse, which is 5. So now I'm going to plug in these values here. So A, I'm going to call it 4, one of the legs. Then I have the other leg, which is B, so B squared. And then my hypotenuse, which we already saw was 5, so 5 squared. So now I need to find the value for B. So that means I need to get rid of everything that is on this side of the equation. So first I'm going to do this. 4 squared is 16 plus B squared equals to 5 squared, which is 25. Okay, again, in order to have B by itself, I need to get rid of the 16 and the power of 2. Which one do I start with? As always, what is farthest away from my variable. So since it's a positive 16, I'm going to subtract 16 on both sides. That cancels the 16, and all I have left on the left side is B squared is equal to 25 minus 16, which is 9. Now I need to get rid of this power of 2. As always, I'm going to do the opposite operation to get rid of it. And what's the opposite operation of power of 2? Square root. So I'm going to square root both sides of the equation. So now, square root of B squared, that's B. Square root of 9 is 3. Okay, so the side B is equal to 3. So that is 3. I do have a video for this part if you don't remember exactly that part, how to do it. And it's called square roots. So you can practice a little bit on that too. The next problem, a word problem. A safe ladder position for reaching 8 feet up a wall, that's my 8 feet, is 2 feet from the base of the ladder to the wall. So that is 2 feet. So how long is a ladder needed? So there's my ladder, and I have the Pythagoras Theorem here. Why do I use Pythagoras Theorem here? Because if you see this drawing, I end up having here a right triangle, and whenever it comes to right triangles, what I'm going to use is Pythagoras Theorem. Now, to be able to use it, the A and B, as we just said before, these are the legs, and the C is the hypotenuse. So I need to find out which are the legs and which one is the hypotenuse. So the side that is right in front of the right triangle, that's the hypotenuse, which in this case, this side. In this case, I don't know what's the length of that side. In fact, that's what I need to find. We will call it just X, which is the length of the ladder. And then the two legs, or the two sides of the right triangles, are 8 and 2. So I'm going to call A 8, and B I'm going to call it 2. It doesn't matter which one I'll call 8 or which one I call 2. Okay, we said that the hypotenuse, we were going to call it X, so X squared. So 8 squared, that's 64, plus 2 squared, that's 4, and X squared is just X squared. 64 plus 8, 64 plus 4, that's 68, is equal to X squared. So I don't want to know what's x squared equal to. I want to know what x is equal to, which means I need to get rid of this power of 2. And how am I going to do that? Again, using the opposite operation, and the opposite operation of power of 2 is square root. So I'm going to square root, as always, both sides. And here I have the square root of x squared, that's just x, and square root of 68. I'm just going to write square root of 68. You can find out the value for that with your calculator. Okay, so that's all. I hope this video helps, and bye.